Hello guys, welcome back to our channel. Okay, this is my third session in NEET series 2021. I hope you people have enjoyed watching the first two sessions, session 1 and session 2. Uh, all the session which we have taken in this particular series is all about scoring a decent marks in NEET, which is somewhere around 130 plus marks. And the strategy I have already discussed in my first session, and you people can actually go to that particular video to get an idea that what exactly we are going to cover in this particular series. Okay, now exam is very close, it's on 12th September, so we have to work it out. This is the third session and the topic which I have taken today is electric current. Electric current and electrostatic, there are a lot of similarity between the two units. So if you have done properly your electrostatic, you would be able to score a decent marks in electric current also. In electric current, the part where you need to understand something is the Kirchhoff part and the applications. I have selected few questions from this particular unit which we are going to practice with me, but you don't have to practice only, you people have to think the way I am going to think about the question, and the idea which you should get when you actually read one particular numerical, what kind of strategies, what kind of a method we can apply on that particular question. So I am going to tell you that, okay? Because we know that there are a lot of questions, we need to understand the way we need to solve the question. So let's start this session by taking the first question, and my first question here is, which says, the magnitude and direction of the current in the circuit shown will be. You have your four options given to you, 7/3, and the current direction is given A to B through point E, which you can see it over here. Similarly, the second option where the current direction is B to A, and then C and D with option 1A, and the direction is B to A and A to B. Okay. The moment you have this question, I don't think there is any problem in concluding that what will be the direction of current in this case. You can see in the circuit we have two batteries. One is 10 volt and the other is 4 volt. So your batteries, you can see it over here. Correct? You have to conclude on the direction part, which can be simply concluded by that your battery, which is bigger in magnitude, which in this case is 10 volt, definitely it's going to be dominate. So what will happen because of that battery, the 10 volt, whatever the terminal sign it's given to you, like this side you can see there is a positive terminal and this is negative, and current always flow from positive to negative. So this entire circuit, if your current moves, it's going to move clockwise. So by simply knowing the magnitude of the battery, we have concluded that what will be the direction of current. So I don't think there should be any problem in concluding that the current direction is going to be A to B. So the option which we have with A to B, you can see A to B through point A and A to B through E. Okay, so I would have taken one of the option if the magnitude is also same, but here the magnitude is 7/3 and 1 amp. Now what we need to do, we need to comment on the magnitude as well. In such cases, when we have to conclude on the magnitude part, I will tell you that how exactly you have to approach so that you can reduce the chances of making any error. When I see this particular question, definitely for magnitude, I have to apply the Kirchhoff law. So before you apply the Kirchhoff law, you people have already concluded that your current direction is going to be clockwise. The moment you decide the current direction, I would say at that particular point what you can do, you can write your sign convention, because sign convention is very important. And what you need to understand, if current is flowing in all the branch in this manner, so you can see A to B, B to C, C to D and D to A. If you apply your Kirchhoff voltage law, which is written as KVL, it simply says the summation of all the potential difference and your EMF in any circuit should be equal to 0. The point here is writing potential difference and EMF. For that, what you need to do, you need to write the potential difference. Writing a potential difference across a resistance is not a problem. You can simply write I into R. For that, what you need to understand that what sign convention you will take. Your current direction is actually the one which will give you the sign convention. So let me tell you, current always move from high potential to low potential. So you can say here it is high potential. On this end of the resistance you have low potential. battery terminal is plus, this is minus, current in the resistor, high potential to low potential. B to C, there is no device, so there is no need to write the plus and minus sign. Again C to D, current flowing from high to low, so plus and minus, and you have written the plus and minus sign everywhere in the circuit. Now what we need to do? Look at the arm A to B. A to B, the first appliance is resistance, which is 1 ohm. I will write 1 and you have to multiply it by the current. So it will look like to you that current multiplied by resistance, which is the voltage, and sign convention you will always write the one from which you are leaving. So everywhere the point from which you are going to leave, I am marking it as circle. So remember one thing, that what I am going to do, I am moving from A, B, C, D, and you have to again write down the same point so that it should become a closed loop. So A, B, C, D, A is my movement, and I am going to write the potential difference and EMF for all the circuit. For A to B, the first appliance which I have counter is my resistance with the 1 ohm. So I have written 1 into I. After that, I have a battery of 10 volt. And from which terminal you are exiting? You are exiting from positive terminal. So it will be plus 10, which is your EMF of battery. The third appliance which you counter is a 4 volt battery, for which you will write minus 4. Then you move on to the next part, which is 2 ohm resistance. So your 2 ohm resistance with the current value I, which is unknown to us, and the sign you will write the one from which you are leaving that particular appliance. B to C, there is no appliance, so there is no need to do anything. And the next one is actually you will write minus, the resistance value is 3, I as it is. You come back to the same initial point from where you have started. This summation should be equal to 0. The moment you write the equation with the help of Kirchhoff voltage law, now we can simply solve it by saying this is 1I, this will also be a minus sign. So you can see the sum here is going to become 5I. And this 10 minus 4, it will give you plus 6. So this is plus 10 minus 4, it is 6, and this sum should be equal to 0. Now when you look at this particular part over here, 10 volt and 4 volt, this is 6, and your total appliance which we have written is 5I. So 2I, wait a minute, the total is actually here is minus 6I. So you can see 2, 3 and 1, it is minus 6I, the sum should be equal to 0. If you take the value on the other side, it will be plus, so your value of current is going to be 6 by 6. So the moment we solve this Kirchhoff equation, what do you get? You get your answer as 1. So this 1 ampere is the one which is going to be the correct answer. So current is going to flow from A to B through point E, which is correct, and the magnitude of current is going to be 1 ampere. So this is the way you need to approach this particular question. The thing which you need to remember is what? That while making an equation of Kirchhoff, it is better to write your sign convention in the diagram itself, so that even if you make any mistake, you would be able to rectify it as quick as possible. Yeah. So the moment you put the sign, make an equation, solve it, you will get your answer. So this is the way you need to approach when there are questions based on Kirchhoff. Let's move to the next question. The next question which we have is resistance. Okay, I can see there is one particular circuit given to me, and the question says the total current supplied to the circular by the battery is. Okay. Now most of the time we actually make mistake when we are not being able to correctly identify whether the resistance are connected in series and parallel. Simple circuit we can make. For that, what we need to do? We need to do the redrawing of this particular circuit, but make sure when you do the redrawing, the circuit should remain same. You can't change the circuit. So actually the name of this technique, which I say, it is the redrawing technique, because redrawing will make things simple for you and you would be able to visualize which resistance is connected in series and parallel. So what I'm going to do, first thing I will identify my 2 points which I'm writing it as A and B, and they are connected to a 6 volt battery. So I will connect, let me show you, this is my point A. So the positive terminal of 6 volt connected to point A and the negative is connected to point B. So I have made my battery first. Now from point A you can see the 2 ohm and 6 ohm both are connected. Okay, so for that what I will do, 2 and 6 both should be connected. So I am going to connect my 2 ohm like this, and then I am going to connect my 6 ohm, and then 2 and 6 are joined together. When 2 and 6 are joined together, you can see this particular point which is C over here. You can also name this as C, and you can see that C is actually connected to one more resistance which is going to have a value which is 1.5 ohm, and that 1.5 ohm is something which is connected to B. Okay, now what about this 3 ohm? Because you can't see anywhere in the diagram, what you can see, the 3 ohm is something which is connected to point A also, and the other end is also connected to point B. So somehow this 3 is connected between A and B, and if you wanted to connect it, you can connect everywhere, but I will simply connect it over here, because my point A and B I can see both, and when I connect it over here, I think the redrawing technique make things very simple, because now I can visualize that what I need to do. Because in this case, I don't think there should be any problem in identifying that this 2 and 6 ohm, they are connected in parallel. And for parallel, we usually go with the formula that R equivalent should be the product of two resistance divided by the addition of two resistance. So if I do 6 into 2, 12, and this is 8. And 12 by 8, if you solve it, which is going to give you 1.5 ohm. So this particular part we have solved. If you again redraw this circuit, 2 and 6 you can combine, and you can say this 1.5 ohm resistance which we have, it is connected in series with this. So these two are in series. For series what we do? We simply add. So I think this entire combination resistance value, if we have to write 1.5 and 1.5 in series, will give you 3 ohm. Now I think we are very close to the R equivalent value, because if I redraw this circuit, this is my battery over here, and from the battery you can see I have my 3 ohm resistance, and then the entire combination which I have solved, it is also coming out as 3 ohm. Now what is the thing which you need to do? I need to calculate the R equivalent. I can see that R equivalent, again I have to go for parallel. So 3 into 3, which will give you 9, and this is 6. Now what you need to do here, R equivalent value you got, you need to give the value of current. I is equal to V over R. So V is 6 volt, R equivalent is 9 over 6. Correct? Okay. Now 3 and 3 will simplify it. It is 3 by 2. So even if I write this as 3 by 2, you can see it over here that 2 and 2 will be 4 amp. So your correct answer for this question is going to be 4 amp. Yeah, guys? What you need to remember, what exactly this method is, whenever you have any particular circuit and you are not been able to relate whether the resistance are connected in series or parallel, what we can do, we can actually redraw the circuit, identify the point which are junction, name them, and see which all resistance are connected to that particular point. And when you redraw it, you rewrite it in such a simple manner that you should be able to identify that which all resistance are connected in series and parallel. So the name of the technique is what? Redrawing circuit technique. Okay, so that is the way we need to do. So this is the correct answer for this particular question, which is option number C. Let's move to the next question, where we have a question which says, in the circuit shown, the value of each resistance is R. Okay, the equivalent resistance of circuit between point A and B will be. It's very important to identify that from where your current is going to be enter and from where it's going to be exit. So point A and B are the 2 points which you can see. Between the 2 points you have to calculate the equivalent resistance. This question is actually false. It is, I can see something, there is an input output symmetry over here, because the way the current is going to enter and the way it's going to exit, there is an input output symmetry. And if I draw my line of symmetry over here, okay, remember when I draw the line of symmetry, you can say that at line of symmetry your potential value is actually 0. So this particular point over here, if your potential is 0, what you can do, there is one particular technique which you can use, because that technique is not going to change your answer, and we say that connection removal technique. Connection removal technique. The techniques are important because when you see a specific diagram, you should be able to relate that which technique we need to apply over here. So I would say you can apply a connection removal technique. So the moment you apply a connection removal technique, just make sure instead of considering this connection to point C, you simply connect this connection is going to be go in this particular manner. The moment you do that, see, the things are going to be very simple, because then you have two resistance connected between A and B. The value is R and R. This is your resistance over here, and this is again these two resistors. If you follow, they look like to me that they are in series. So what I can do, I can simplify them and I can say this is 2R and this is the same diagram. Everywhere the resistance value is R, so I will write it as, this is only one particular part which I have solved, which has been written as 2R. What we can do, again identify, this is parallel. If you solve for this part, it will be 2R square by 3R. So basically your R equivalent value for R and 2R come out as 2R by 3. You can see this R and this R, they are in series, so you can add them up. So this upper arm which you have, for this if you actually solve it, you are going to get, this is 2R plus, if you make it 2R, this will be 6R by 3. So this upper arm result is going to be 8R by 3. Now you got the upper arm. This is what? This is your, again, the two connections are in series, the R equivalent is going to be 2R. Now we just need to solve for 2R and 8R by 3. But when you see that, remember there are two arms. So the final combination, if you look, this is how it's going to be appear to you. And what we can see over here, that these two are in parallel. So if we solve it, I think we will get the answer. So I will show you over here that how you can solve. You can simply say the product of 2, which is 8R by 3 multiplied by 2R divided by 8R by 3 plus 2R. Now if we solve this particular part over here, it will be 16R by 3 divided by, this is your 3 as it is, this will be 6, 14R by 3, this is going to be R square. 3 get cancelled, 16R square by 14R, you cancel this. Now 16 by 14, what we can write? 8 by 7R. So my final answer which I have, I can see it over here, which is option number D. There are a lot of questions, even if you have to calculate the voltage or current. Remember, the very first step can be that find the R equivalent value. Means in this entire particular unit, if you see, the technique to solve your R equivalent is very important, and for that you should be able to visualize the different component which has been given in that particular circuit. There are different techniques which we can use, but make sure these techniques are applicable, like redrawing circuit. Wherever you feel like the circuit is very complicated, redrawing technique. Input output symmetry, you can have any other circuit diagram also, but you should be able to relate that if it is an input output symmetry, what you can do, you can use my connection removal technique over there, and then you can solve your R equivalent. So you people have to remember the name of the technique which I am writing, which is very important. So if you have a similar kind of a question, you can definitely approach that question with that particular approach. Okay. Now let's move on to the next question which we have over here, which is question number 4. Okay. Question number 4, it says the figure here shows a portion of a circuit. What are the magnitude and direction of the current I in the lower right hand wire? So we need to calculate this value of current. Definitely they have not given you the direction, but what you need to understand here, that we are going to make use of Kirchhoff current law, because Kirchhoff current law says that sum of the current at the junction should be 0, or you can say that whatever the current enter into the junction, the same current is going to exit the junction. So this whole thing is about the junction rule. You can see it over here at this particular junction, the total current enter is 2 amp and 3 amp. That means this arm is going to have 5 amp over here. So when you solve such kind of a question, you just keep on writing the current value, which you can conclude by simply looking at the junction. The next junction which I have over here, definitely 5 amp is going to be enter from here, but I can see in the above the total is 2 amp and 1 amp. Mean the total current which should come out from the junction, the choice is it should be 3 amp, because whatever current is enter, that is the same amount of current should exit. As I know the value of current given in the upper part of the circuit, I can conclude that the upper should be 3 amp, then only you can see 2 and 1 is going to leave the junction. Now 5 amp is enter into the junction, 3 amp has gone up, definitely the remaining will go down only, there is no other choice. Now again, if I look at this particular junction over here, I can see that 2 amp and 4 amp are the two current entering into the junction. That means the total will come out is what, 2 plus 4, which is going to be 6 amp. Now somehow I have reached to this conclusion that the current value which they have asked me, what I can do, that current which is going to be enter into the junction from this side is 2 amp, which is given to you. You have concluded from the other side it will be 6 amp. So the total current which is going to be enter into the junction is going to be 6 plus 2. That means the current which is going to be leave the junction is going to be 8 amp. I think you people can see one of the option which has been given in this particular question, that 8 amp is the current which is going to be exit. So that is what the value of I is going to be. So for question number 4, if you have to select the right answer, our right answer is going to be 8 amp. I hope this technique is clear to you. It's a very simple approach, but this approach you can apply to make sure that you are not going to commit any kind of a mistake. Because when we talk about Kirchhoff current rule or the KCL, Kirchhoff current law, the junction rule is very simple in terms of statement that the current at the junction should be 0, or the sum of current which is going to be enter and the one which is going to be exit should be same. But how to apply it, this is what the technique is which you can use and you can get the right answer. Okay, moving ahead with our next question where it says find current in 6 ohm. Now most of the time things get very complicated when the information given in a question is very less, because I know that if I have to calculate the current, my usually formula is V over R. And usually what people do, they actually think about that how we can calculate this particular value of V. Definitely that should be your aim, because that is what the formula requires. R value, I can see in the circuit that R value they specifically want me to calculate for 6 ohm. So if I say that this current over here is I1, this current over here is I2, because my current is going to get divided, means my aim is to calculate the value of I2. Let me tell you what we can do. In this particular case, even if someone wants to apply the Kirchhoff, you can apply and you can get the value of I. But you need to understand one particular thing, that we need the value of I2. And if there are 2 unknowns, you require 2 equations. I'm going to do what? I'm going to simply say that I know that what exactly the sum of current which is going to be entered into the circuit. So if I know that, I should be able to calculate the voltage at point A and B. And for that I can use the formula that voltage is going to be I into R. Now you need to be very careful. What do you know? The total current which is getting into the circuit, which is 18 amp. So the value of R which you will write, what you will write? You will write the total resistance, which is known as your R equivalent, and for R equivalent value for 6 and 3, you can see it is 6 into 3 product at the numerator and addition at the denominator. So 18 by 9, which is simply going to give you 2. The voltage value which you have, it is 36 volt. If you have this value of voltage, I think there is no problem or there is no harm in calculating that I2 value can be calculated by 36 divided by 6, and it's going to be 6 amp. The reason for that is what? The 3 ohm and 6 ohm are connected in parallel, and for parallel what is going to be happen? The voltage is going to be remain same. This is a fundamental rule which we know that. That's the reason we can simply say that the value of current, we can conclude it's going to be 6 amp. Very basic approach, but you need to understand the value which you are considering, the value which you are taking. The similar way you people have to approach that question, and you can break the question according to you. There can be a different method also, but this is the easiest method which we can apply and we can get the answer. Okay. Now let's move to the next part, which is question number 6. Question number 6 is also, the circuit looks a bit complicated because it's an open circuit from every single corner, you can see that. But what you need to understand that I have this particular junction and I can see the amount of current which is entering into the junction. So that is 1 amp and your X value, and the one which is leaving the junction is your 3 amp plus 5 amp. Aim is to calculate X, very simple. It is 8 and you take 1 to the other side, that means it is going to be 7 amp. So by using my Kirchhoff junction rule, I would be able to calculate the value of current over here. Okay, simple question, and I hope you people understood what we have to do it over here. Let's move on to the next question. Question number 7. Question number 7 here, if you see, it says find current in 2 ohm resistance. The aim is to calculate the current through 2 ohm resistance. Definitely Kirchhoff we have to use, but let me tell you, for entrance we usually don't apply Kirchhoff in such questions because it's a long method. So when you see any such circuit, I hope you people remember that even in electrostatic there is one particular technique which I told you, which is the technique I name it as T junction. T junction. Whenever you have any T junction, which you can notice over here, that 1 ohm, 3 ohm and 2 ohm, they are connected in such a way that you get a T junction, you can assume that the potential at point A is X, and then you can solve this particular question. What we need to do it over here, you need to understand one particular thing over here, that is the option which are given are in ratios. So we would recommend that we have to solve in such a way that our ratio value should be able to relate. Otherwise you will get some decimal value, and that you need to understand. So it's okay, I'll try to figure it out in terms of a ratio. So what we are going to do, I have assumed my potential at point A as X. According to the Kirchhoff, there will be some value of current flowing through. I am taking I1, I2 and I3 are the current value in 3 particular arm. Our aim is to calculate the current passing through the 2 ohm resistor. For that, definitely I am going to calculate my I2 value. What you people need to understand, you might be having this question that how come all the current are entering into the junction? See, when we use the Kirchhoff rule, there is no specific condition which has given like how you should take the value of current. I know that one of the value of current is definitely I have taken wrong, but that's not something I should be worried about, because when I'm going to get my answer, I'm going to get my answer in terms of negative, which I can simply say that whatever the direction I have shown in the diagram, the current is actually moving opposite to that direction. So this question should not come to you that how come the 3 direction can be shown into the junction. It can be shown, that's okay. But when you solve, the Kirchhoff ultimately take care of it. So you don't have to worry about that part. What I can say is that according to Kirchhoff, my I1, I2 plus I3, this sum should be equal to 0 at the junction. And when I see the formula that current, it should be V over R. So what I'm going to do, I'm going to write the value of I1. X, the value which I am considering, I consider it as at a high potential, and I don't know what it is exactly, but we will calculate it. So I say X minus 10 is the potential difference for 1 ohm resistor in X minus 10 divided by R. This is my first value for I1. Similarly for I2 I am going to write that X minus 6 and the resistance is 2 ohm. For I3 I am going to write X minus 3, so it will be plus 3 divided by 3, this sum should be equal to 0. So by this particular technique, guys, what we can do, we can actually calculate the value of X. And when I calculate the value of X, I can say that here X minus 10, so I will do one thing, I will take the LCM directly. So you can see the LCM is going to be 6, it is 6x minus 60, this is 3x minus 18, this is 2x, and this is 6. Sum should be equal to 0, the 6 at the denominator, even if you take it to the other side, it's going to be 0. So we have 6x, 3x, which is going to make it 9x plus 2x, which 11x. So 11x. 60, 18 and 6. So 60 and 18 will make it 78, and if you subtract 6 from it, I think it will be 72. So minus 72 is something which you take it to the other side, it will be 72. My X value is 72 by 11. When I do the value of X as 72 by 11, guys, we got this. What is this? This is a potential difference, because that is what we have considered. The potential at point A is X. Now when you see the I2 value, I2 can be calculated because that is the only value in which we are interested in. It is 72 by 11 minus 6, and the resistance is given as 2 ohm. Now here what you can do, guys, you can actually solve this. So what are you going to get? 72 minus 6. So again, if you take LCM, it will be 22, and 72 minus 66, it's going to give you 6. So 6 by 22, which is going to be 3 by 11, because 2 3s are 6 and 2 11. So I think my value of current which I am going to get for I2, I can conclude that this is what the value of current is. One of the option you can see in the question, it's B, and you can see that for this question the option B is correct. Guys, I have taken time so that I can explain you, but if you actually see, the number of steps which are involved in calculating the current value is only 2 steps. One, get the value of X. The moment you get the value of X, then you can simply use the equation that potential difference at 2 points subtracted by, potential difference at the 2 point divided by the R value which is present over there, and accordingly. You can use the same technique to calculate the value of I3 also. For I3 you will do what? You will do 72 by 11 plus 3 divided by 3. You can use the same technique to calculate the value of I1 as well. And let me tell you, when you solve it, you actually get the sign also, and you can stick to that particular sign. Is that okay? So I hope this question is also clear to you. So when you solve this question, the technique name which we have over here, the technique name is T-junction technique. Okay? So this is my question 7. Let's move on to question number 8. Okay. Question number 8 is again a simple question, but most of the time what people do, they actually spend a lot of time in calculating this particular value over here. What you need to understand, it's a simple question which says that the length of a resistor wire is increased by 10%. What is the corresponding change in the resistor wire? I'll show you the long method which you're going to apply, but I want you to remember one particular relation which you can directly use in the exam. Okay? Because I know that what people do, they consider that in case if the original length, let's say it is 100L, and the new length you have, it's going to be 110 by L, because it is 10% increase. One particular logic which we can always apply is that my volume is something which is never going to be changed. So whatever your initial volume is, the final volume will also remain same, and volume is something which can be written in terms of length multiplied by area. So I am writing L1 A1 L2 A2, from where you can write a relation that L1 by L2 equal to A2 by A1, or you can also write L2 by L1 equal to A1 by A2, reciprocal, both are same thing. What do people need to do? You need to calculate the new resistance. Now for that, the formula is what? That your initial resistance value can be written as R1 L1 A1, and your new resistance value can be written as L2 A2. Aim is to calculate R2 value, so if I divide my second equation by 1, you will find R2 by R1. Your rho is something which is resistivity of the material, which never changes for the same material. So you are changing the dimension of the same material, so rho will remain same. So the moment you take a ratio, you get rid of rho, it will get cancelled. What you will get is, you will get L2 A2, and this R1 you will get L1 A1. You know the change in length has been given to you. So what we can do, we'll write L2 by L1, and this is A1 by A2. If you know the change in length, you better do one thing. A1 and A2 is something which can be substituted from here, because A1 and A2 is nothing, it is L2 over L1. So guys, what we can write, that my resistance value, if I plug the value of A1 by A2 as L2 by L1, it should be L2 by L1 the whole square, and this is R2 over R1. I want you people to directly remember this particular step which I put it as a star, and whenever you have any kind of a question, you just directly jump to this conclusion that R2 by R1 should be equal to L2 over L1 square, and you start from there. So you can see that how much time you can save, and this much time is very important when it comes to the entrance exam. So if I directly know that R2 by R1 is equal to L2 by L1, I can directly solve it from there. Now let me show you, like if you avoid this much part, because you already know this, what we can do, R2 we need to calculate, the L2 value is 110 L, and your original value is this. Taking a square of it, you can cancel L and N. This will be 121 divided by 100, which is R2 by R1. So you get your R2 value as 1.21 times the R. You're getting my point? Question says the change means R2 minus R1 upon the original value multiplied by 100. So when you do R2, which is 1.21 R1, R1 is as it is, this is also R1, and then multiplied by 100. So what do you get? 0.21 R by R into 100. Your RR get cancelled. You simply get that 21% is going to be change in your resistance which you are going to observe for this particular wire, for which you have changed the length by 10%. So the red part is something which you should know. There is no need in wasting the time and showing this particular calculation to the examiner. You directly remember the formula that R2 by R1 is equal to L2 by L1 the whole square. The same thing can also be written in terms of area also. So if you write in terms of area, it will be A1 by A2 the whole square, and whatever the area percentage change has been given to you, directly plug it and you will get your answer. So this is one particular method which you can use, and you can save a lot of time, because the concept is very simple. The only thing is, don't spend too much time in calculation. You can utilize that particular time somewhere else where it's actually required. Okay, so this is lengthy calculation, appears to be, but you can reduce half of the calculation, or I can say 75% of the calculation you can remove. Use directly start from the value which I put it inside a bracket and put a star. Okay, now guys, let's move on to the next question. The next question which we have over here is question number 9, which says find the equivalent resistance across the terminal of source of EMF. Okay. Question is about R equivalent. Again, the moment I see the circuit is a bit complicated for me, and what I can do, I can use one particular technique which I told you is the redrawing technique. So when you redraw this circuit, and you redraw in such a way that whichever thing you can simplify or you can conclude, you solve it and write it over there. But every time redrawing should be done by using the battery. So let me show you first. This is negative terminal of the battery, this is positive terminal of the battery, because battery terminals are very important. Now when I see from the terminal this 8 ohm and 8 ohm, they are the one which look like parallel to me. So what I can do, I can make this particular part, that 8 and 8 in parallel, that means 64 by 16, which will give you 4 ohm, and this 6 ohm is in series with this particular connection. So I can see that this entire thing over here, if you calculate, you're going to get your resistance at 10 ohm. And this I'm going to connect, so this positive and negative, this entire part over here is 10 ohm. So let's simplify it one and write it down in this way. Now this part we need to think. From negative terminal you can see a 4 ohm has been connected. So let's connect a 4 ohm in this manner. Then this 4 ohm has been connected to 15 and 10 both. So you write 15 and 10, make two resistance over here, 15 and 10. And then 15 and 10 are actually joined together and they have given the connection to the positive terminal of the battery. I will just simply make it look like this. Now what you can do, I have placed the battery in between. This 10 ohm, even if you shift it upward, it will appear to be parallel. So you can solve this particular part over here. First thing, so it will be 150, the product of 2, and the denominator is always the addition of 2. So you will get this particular part as 6 ohm and 4 ohm. They are in series. So what you can see, that the battery is given to you. This is 10 ohm down, this is 10 ohm up. Even in this case, if someone draw the diagram, positive negative terminal, this is 10 ohm, this is 10 ohm. They all actually convey the same information. Whichever circuit I have drawn in this particular slide, let me tell you, all the diagram are exactly the same. It is just the different way of redrawing it, but they actually convey you the same information. So what you need to do, the end thing is, I think it is the parallel of 10 and 10, which will give you 10 into 10 product. So it will, denominator is always the addition. So when you solve it, 100 by 20, which is going to be give you 5 ohm. So 10 by 5, your 10 by 2, the answer will be 5 ohm. So for this particular circuit, the final answer is going to be the 5 ohm is your R equivalent value. Again, the technique which we have used over here, the name of the technique is redrawing the circuit, and then you are able to calculate the R equivalent value. So redrawing technique is very important. Okay. Okay guys, let's move to the next question over here. The next question which we have in this part. Okay. In the circuit shown in figure, which switch S1 is initially closed, you can see switch S1 is given over here and S2 is open. Find voltage VA minus VB. That means this is point A and this is point B. You have to give the potential difference between these 2 points. Now what we need to do, guys? The circuit is very simple because they have said S2 is open. Even if S2 is closed, let me tell you that you have capacitor over there, and if it is a condition of a steady state, the capacitor is not going to allow the flow of current through it. So there are two situations can be asked for this particular question. Yeah. In a steady state, we know that current is not going to be allowed by the capacitor, but if S2 is not even connected, what we can do, we can simply redraw this circuit. So I am not going to change anything. S1 I am simply not considering because I am considering that S1 switch is closed. Your diagram which you have, I can see it, that you have 1 ohm, you have 5 ohm, you have 3 ohm at the denominator, and there are one more 3 ohm, and the circuit look like this. Guys, let me tell you, this circuit and the circuit which I have drawn, in which I have avoided the arm which is present between A and B, both the circuit are same. There is no difference between the two particular diagram, because one thing which you need to understand is this, that capacitor will definitely not allow the flow of current, and if S2 switch is also open, that means you can even ignore the particular arm and you can say that this is how the diagram will look like. What do you know? You know the 24 volt. The question says find the potential difference between the point A and B. Interesting. Now what you can do, guys? First thing you can do is actually you can say that my battery appears to be connected parallel to this combination and this combination. So both the combination which I can see, my battery is connected in parallel. So in case if I have to calculate the value of I1 and I2, because definitely some current will flow through the circuit at the junction, the current is going to get divided. So the current which you have in the upper arm is I1, and let's say the current which you have in the lower arm is I2. If I am able to conclude this value of I1 and I2, which I can do, because I1 is V over R. If I am writing the total voltage is 24, let me tell you the total current present in this arm you are calculating. So you have to take R equivalent value in that arm, and that is 6, which I can say 4 amp is the value of current for I1. Okay, means in the upper arm the amount of current which is flowing is 4 amp. Similar technique can be used to calculate that what will be the current I2. For I2 again I will say 24 is the voltage, and this particular arm the total resistance is also 6. So I don't think the value of current will be different, because both the arms are actually having the same amount of resistance. So whatever the current you have, it has been divided equally into two parts. So the total current which is coming out of the battery is 8 ampere. The question is about what is the voltage between A and B. What I can do, guys, let's see. If I say at this particular junction, if my name it as point O, VO higher potential, VA lower potential, and this potential difference can be written as I into R. The value of I is 4 and the resistance which is present over there. So that means VO minus VA is 4 volt. Similarly, make an equation for VO and point B minus VB, and your resistance value is 3, current value is 4. So 4 into 3, that means VO minus VB potential difference is going to be 12 volt. So somehow I actually get the potential difference between OA and OB. If you look at the two equations, VO minus VA equal to 4 volt, VO minus VB equal to 12 volt, what you can do, you can subtract this particular equation, because you need to get, okay, you need to get VA minus VB. So let's change the sign of the first equation, so that this is minus, so I'm changing the sign for this. I think this will get cancelled. You get VA minus VB, 12 minus 4, 8 volt. I think this is what exactly the question has been asked to you, and you are able to solve it by simply solving the two equations which we get, and your correct answer is going to be 8 volt. Yeah? So guys, question in electric current, they are interesting, and the only thing which you need to remember, that you just need to know that what exactly the correct approach to solve that question. Yeah? So even if you know the formula but you don't use it correctly, or you don't identify the circuit correctly, you don't identify the appliance which has been connected in the circuit in a correct pattern, whether they are in series and parallel, there are chances that you can make a mistake. So every single question when you solve, you can always relate when you actually name that particular technique, and you just try to relate whether the same technique is available to you, and the same technique whether you can use it or not. So this technique which I have used, again, I again say this is actually the redrawing the circuit and make it in a simple manner, and then I have made two equation. I have concluded that what will be the potential difference between A and B. Okay. Now let's move to the next question. The next question, it says again, now if you see in this particular part, there are a lot of questions which are based on R equivalent value, because for R equivalent there are so many techniques and method available to us, but usually in the exam there are specific techniques which are very frequent, and examiner actually tests you most of the time on those techniques. Looking at the diagram, don't be nervous, don't be confused, just simply try to concentrate that what exactly you know, what you can do about it. What I can do over here, let me tell you. This arm over here, I am going to ignore this because they are not connected to anything. And then if I redraw the circuit, I can simply identify one particular part, that this over here and this thing over here. These three resistors are look like parallel to me, and when you solve for 1 by R, 1 by R, 1 by R, the value of R equivalent will be R by 3, and this will also be R by 3. Okay. If I ignore, if I neglect this particular part, I can see this over here and this resistor over here. They look like to me they are in series, and I can write it as 2R. So this is my first observation for this particular diagram. Now look here, when I actually draw it, how simple it looked to me by saying that this is point A, where you can see this part you have calculated R by 3, and this is your R as it is. This is 2R, and then this particular point which is given to point B, you have, let me show you, this is actually connected in this way. Here you have it's actually correct over here. This is R by 3, this is R by 3. Point B, and this is, you have already concluded, it is 2R. Okay. Read on the circuit looks a bit simple to me now. What I need to do over here, I will say, okay, this is the part which I'm again, I think this is your R by 3, and this is okay, this is look appropriate. Okay, what we can do, guys, we need to calculate between A and B. This part you can again solve. If you solve this part, R and 2 are in parallel, what you will get? 2R square, 3R, this you can cancel, your answer will be 2 by 3R. The same thing you are going to get it over here. So I think you can remember this particular part. Now what you can understand, this 2R by 3 and R by 3 which you have over here, they are in series with each other. So R by 3. So when I solve it, I think I'm going to get it as R. So this entire connection below point AB appears to be R, and this is also exactly the same because you can see the symmetry between the two. So even if you solve this part, I think you will going to get R. So there is no point in wasting the time in calculating it again, because all the value which you have written, they are exactly the same. You can see the two resistors which we have, they are in parallel to each other, and if you solve for them, it will be R square plus 2R. So your R by 2 should be the correct value in this particular case. Yeah. So this approach which we have over here, you need to understand that this technique is also redrawing technique only, but you people have to figure out the diagram, like which all resistance you people can solve and you can merge them. So instead of drawing multiple resistance, just draw one. So the circuit diagram, it actually gets simplified to you. And that simplified circuit diagram when you have, you can actually go step by step to make it much more simplified. So what you need to understand, the diagram which we have in the beginning, this is what the diagram given to us by the examiner. But the point here is, this diagram and this diagram, they're exactly the same. So if we only know the redrawing technique and if we simplify our circuit, then only there is a possibility that we can get the right answer. Because if you try to do this question directly from the diagram which is given to you by the examiner, definitely you will get confused and there is a chance that you can make some mistake. Yeah. So redrawing technique make things very simple for you, and simplified circuit give you a correct understanding of the appliance connected in series and parallel. Okay. So our question number 11 is done. The correct answer is R by 2. Let's move on to the next question which we have over here. And this is my next question, which is, in the circuit shown in figure, find the current through the branch BD. Now most of the time people actually look at this particular circuit and they see there are multiple batteries connected. Let's go for a Kirchhoff and calculate it. But let me tell you, Kirchhoff is actually one particular method which is a bit hectic, and even if you get into that Kirchhoff method, the process is going to be a bit long. What we can do, we can use one particular technique over here, and I told you the name of that technique. If you use it, you'll find things in a very simple way. Yeah. So if you remember that particular technique which we have, I also gave name to that particular technique, and the name of that technique is what? It is the T-junction technique. If you actually look at this particular diagram, this B and D point has been given to you, A and C also in there. I can draw my diagram for this particular part. In the previous question what we have seen, the examiner has only given us a T-junction. But in this, there are complete circuit which you can see, but somehow I can make this question exactly look like my T-junction question. So what I'm going to do, guys, this is 6 ohm given to you. This is your point B. This is your 3 ohm and this is your point C. So point A and C I'm not going to touch or change, I'll keep it as it is. And this is my 3 ohm and then point D. Now the diagram look like a T-junction to me, but remember, battery part, point A is connected to positive 15 volt, better you write down over there. Point C is connected to plus 30 volt, you better write it down there, so that this is how your question will look like. And now I think I can approach this question. Even you people have solved one particular question with me in this session, which I have used the T-junction technique. You can use the same technique and you can get the answer. But first you should be able to relate that how this diagram can be related to that particular technique. So now what we have to do, guys, consider your potential at point B X, and point D you can consider 0 because there is nothing which has been given to you. So you can consider that point as 0. Now what I am going to do, current I1, I2, I3. I told you that the sum of the current in the junction should be equal to 0. So I1 plus I2, I3 sum should be equal to 0. Definitely we don't bother which current is enter, which current exit, that we can conclude later. First aim is to calculate the value of BD. The point here is, which I'm trying to explain you, that most of the time when you actually go for Kirchhoff method, Kirchhoff can lead to a wrong answer because there is a very high chance that people can do mistake in the sign convention part. So to avoid the sign convention part, I'm giving you this particular technique, which is going to save a lot of time. At the same time, this technique will always give you a correct answer. Okay, now what we need to do, I have written I1, I2, I3. Now you people know the value of current can be written as voltage over resistance. So when you write I1, it is X minus 15 and the resistance is given as 6 plus X minus 0, the value of resistance is 3 plus X minus 30, the value of resistance is 3 ohm. So 633, you can see the resistance I have written at the denominator, and you can see that the value of potential difference I have written on the top, this sum should be equal to 0. Okay, now what we need to do? Simplify, get the value of X. So for X value, what I am going to do, my LCM here is 6, so I can say this is X minus 15 2x plus 2x minus 60, 2x, 2x, 4x and 5x. So 5x, 15 and 60 is going to give me 75. Sum should be equal to 0. That means 5x equal to 75. I think we can get the value of x by 75 divided by 5. So 15 volt is the potential which is present at point x. Because now I think the moment you get the potential part, it doesn't matter whether you have to give the value of I1, I2, I3, because all the values can be given by you, because now you know that where the potential is high, where the potential is low. The question says calculate the potential, the question says calculate the current through BD. So what we are going to do? Current through BD, if you have to give, I can simply say that current value I have named is that I2. So I2 should be equal to 15 minus 0 and the value of resistance present is 3. So I2 value is going to be 15 by 3, which is going to give it as 5 ampere. See guys, that I get my answer quickly by using this particular technique which we say T-junction technique. The point here is you don't have to bother about the sign convention part, and you directly get the value of x and you can calculate. It is not only about the value I2 which we have calculated. You can give the value of I1 also, you can give the value of I2 also. So it doesn't matter which value of current examiner asks you, you can actually calculate the correct and precise value of current through this particular technique. So that is what you need to understand, that how you are going to use this particular method, and when you use it, just make sure that there are only 2 steps which are involved, and you check whether you are able to relate with this T junction in a circuit or not. Because the moment you see this T junction is there and you can relate this particular technique over there, use it and you will get the right answer. Okay, now let's move on to the next question, guys. So our next question is a battery of 24 cells, each of EMF 1.5 volt. Internal resistance is also given to you, which is 2 ohm, connected in order to send the maximum current through a 12 ohm resistor. 12 ohm is your external resistance which you have connected. Now if you actually see, this particular question is actually a mixed combination. So you have cells which can be present in series, you have cells which can also be present in parallel. So when you have a mixed combination of series and parallel, I hope you people, first thing which you need to know, which is very important over here, which I will highlight, it says maximum current. For maximum current, you should be able to relate that your value of Imax, the condition for Imax is what? That capital R should be N times small r divided by M. So this is one particular formula which you need to remember. Okay, how do we derive it? There are simple way to derive this particular part, but Imax, this is what the condition is for mixed combination, which I want you people to remember, because if anyone who is thinking that what exactly this N is, basically this N is number of batteries which has been given to you, and in this case my number of batteries is 24, and when you talk about M, guys, my M actually stands for rows. So what you need to understand, the product of n into m, rows into column, it is not going to be exceed 24. Yeah, so this is something which we know. Okay, by the formula, by the equation, we have seen that n into m sum should be equal to 24. Now what we can do, we can calculate this after having a bit of knowledge about the mixed combination, Imax condition, and n into m should be equal to 24. Now this part, if you see, external load value is 12, the value of n into your internal resistance is 2 and m as it is, because I have no idea what will be the number of batteries connected in series and parallel. So I am just simply figuring it out that what relation I can give between n and m. For that, what I can do, I can say that 12m equal to 2n, so basically your n equal to 6m, which I am getting, which I can say is my first equation. I already know this particular equation, let's name it as second, because by using these two equations, I can do what? I can actually calculate the value of m. So if you see, the n equal to 6m, so if I use it over here, n equal to 6m square, this is 24, that means the value of m is going to be 2. Guys, I think you people have an idea that number of rows which we require is 2 rows. If you require 2 rows of batteries, then definitely in every row the number of battery which will be present will be what? It will be 12 number of batteries. So if you get the value of m equal to 2, the value of n is going to be, you can calculate. So the number of batteries, 6 into m, which is, so the number of batteries which you are going to connect in series, there are 12. So 12 batteries in series, and there are 2 rows, which you can see that will be the one which will give you the desired result. So instead of going for a permutation and combination and checking whether you get this answer or not, I would say this is one particular method which you can use. The important formula are the one which I have made the cloud, which you should know, and then relating the n and m, I think now we are able to say the right answer is what? In this case, 2 rows of 12 cells connected in parallel, or the answer for this question will be what? We have 2 rows and 12 cells connected in parallel, that is, you have n equal to 12. Here the number of total batteries is given to 24. So you have this 12 batteries which you are going to connect in parallel. So 2 rows of 12 cells connected in parallel, that is what the right answer going to be there, because rest all the combination which you can see, they are not appropriate in this particular method. So 2 rows and 12 cells in parallel, 12 cells in parallel. Yeah, okay guys, question is about the mixed combination of a cell. So usually people have done the batteries in series and batteries in parallel. So you should not get confused about this particular part, because batteries in series, batteries in parallel, and this is a mixed combination where you have series and parallel both connected in one particular. So for all 3 arrangement, let me tell you, the condition for Imax can be different, and you people have to remember for Imax condition for all 3 cases. So that's the reason you have to be very careful when you are solving such kind of a question. Questions are straight, questions are easy, but the only thing, sometimes we get confused when we actually try to relate with something else. Yeah, so even I was writing something because I was under the impression series or parallel, but this is a mixed combination question. So you have to be very careful that cells which we have connected are going to be in this particular manner. Okay, Now let's move to the next question here. The question says in circuit as shown in the figure, the value of R is 46, current through 20 ohm resistance is 0.1, potential difference across the middle resistance is 2 volt. So what we are going to do, we are going to definitely try every single part and we will see whether the given answer is correct or not, and whichever answer we get different, we will simply say that the answer is not there. Okay, now resistance value, if you have to calculate this, what you can do, these three are in parallel. So 1 by 10 plus 1 by 10 plus 1 by 20. So first you can calculate this R equivalent value. Because the moment you calculate this, you will get this as 20 by 5, which is 4 ohm. Now 4 ohm is something which you know. So if you redraw the circuit, what you will see, battery of 25 volt is able to supply a current of 0.5 amp, and you have here R which is connected, look here, very important, this R is connected in series with this. So you have here the answer as 4 ohm. Okay. Now we need to get this value, the value of R. 0.5, I hope you people know that I is equal to V over R. The I value is 0.5, the voltage value is 25, and these two things are in series, so I can say R plus 4. So our aim is to calculate the value of R, take it to the other side. So what will be 0.5 R, this is 0.5 multiplied by 2 multiplied by 4, so 20, this is 25. So you will see that this is going to be R equal to 23, 0.5, this is 10, so 46 ohm is the value of R. So I think what they have given is absolutely correct, that the resistance value, R value is 46. Okay, sorted, not a problem. Current through 20 ohm resistance is 0.1. In the circuit, 0.1 is the value of current which has been given. You have to calculate whether this current is same or not. Now 0.5 has been given. One thing which you need to do when you actually use the formula that I is equal to V by R, you have to be very careful that there is some voltage drop which is going to be happen over here. So this voltage drop can be calculated by that the V value is IR, and I hope you people know the current which is coming to the battery is 0.5, and R value we just now concluded that it is going to be 45. So what you can say that the value, the voltage which has been, 46 is the value. So the voltage drop which you have over here is 23 volt. 23 volt is the voltage drop across this R. Mean the remaining voltage which you have, it's only 2 volt, because total supply is 25. 23 voltage is the one which has been taken by this R value, capital R. So the remaining voltage, let me tell you, the voltage for these three which are connected in series, it's going to remain same. So when you write 2 by 10, the answer is, 2 by 20, because resistance is 20. So answer will be 1 by 10, which is 0.1 amp is absolutely correct. So I think my second option is also correct, guys. Yeah. Now the question comes, potential difference across the middle resistance is 2 volt. I think for that we don't need to calculate anything, because just now I told you that this 10 ohm and 20 ohm, they are connected in parallel, and for a parallel circuit there is no way that the connection, the voltage value will be different. It will be same. We have learned this. Voltage in parallel remain the same. So what you need to understand, guys, over here, that whenever it comes to the question on electric current, calculating R equivalent is very important, and R equivalent is something which you can also relate with the way we calculate capacitance. The formula is different, they are actually vice versa, but what you need to understand, let it be a question of capacitance, let it be a question of resistance, you should be able to identify. The technique which we have discussed over here, the same technique is also applicable in capacitance also. Yeah, just be careful with the formula. Now, different name I have given to the technique. So in case if you people are going to practice, always try to understand whether you are able to relate with that particular technique or not. When you see a circuit diagram, whether we should go for redrawing, whether there is an input output symmetry, whether there should be a connection removal technique. So there are various techniques which are available to us. You just need to pick the correct one. And the moment you identify the circuit according to that particular technique, then things are going to be very simple. You can directly solve the question and you will get the answer. Yeah, I hope all the questions which I have discussed in today's session are clear to you. You can practice similar kind of a question, because practice is something which is very important. The more you repeat, the more you will retain. So it is better to practice similar kind of a question. Yeah, and whichever technique I have discussed, see whether you are able to relate that that technique is applicable over there or not, because you people already have the answer after using the technique. Even if there is some different method has been given to you, or you have learned some different method, you can use my technique and let me tell you that you will get the same correct answer in a very short span of time, because entrance is all about time saving. Yeah, so guys, this today's session I am going to edit over here. Thank you very much, and we'll see you again in my next session. Till then, bye bye.